Let's take a look at an example of graphing the following trig function. So we have y equal to 4 times the sine of 3x plus pi minus 2. So in your notes that you printed off, the very first thing you need to do is make it fit the form that is seen there. So to do that, since I have 3x plus pi, since this 3 is not factored out, it is not in the form that I need it to be. So I'm going to have to factor that 3 out. Now again, you only have to factor out if A, the value right in front of x is not already factored out, or in this case, if you didn't have, like we have pi there, if we didn't have that, if we just had the 3x, there would be no need to factor out. But since I have 3x plus pi, and that 3 has not already been factored out, I'm going to have to factor that out. And you have to make it fit that form first. So to do that, that'll give us y equal to 4 times the sine of, and I'm going to put some brackets here, I'm going to factor out the 3, so 3 times, if I factor out 3, I've got to fix both terms in there, so they would be what they need to be if I were to distribute the 3 back in there. So to get it back to 3x, I would just have to put x right there, plus, and to get back to pi, I would have to put pi over 3 in there. Then minus 2. So you need to make it fit that form just for some different reasons. It helps you better identify all the different values you have in there, and you'll make less mistakes if you'll make it fit that form. Okay, the next thing is we have to make sure that b is positive, and in this case, the 3, that is our value for b, and that value is positive, so we're good there. So I'll go ahead and make a note of that. My value for b is 3, and that is greater than 0. So we're good there. The third thing is we need the value for a. Now for sine and for cosine, that value for a in absolute value is the amplitude of that function. So in this case, since we're looking at sine, my value for a is 4, and so that means that we have an amplitude of 4. And the amplitude is used in some different application types of problems, but for us, we just need to know what the value is, and that value for a is 4. So that tells us we're going to be 4 units above and below the center line. It's the importance of that value for a. It tells you how many units you are above and below the center line. Fourth thing here, let's scroll my paper down a little bit here. Fourth thing here is we need to know what the value is for d, which is, again, our vertical shift. Well, in this case, our value for d is negative 2, so we have a vertical shift downward of 2 units. So that means that our new center line is no longer the x-axis. Our new center line is y equal to negative 2. And again, that's important because that value for a tells us we're going to be 4 units above and below our center line, which is now at y equal to negative 2. All right, so now I'm going to use, sorry, I'm going to scroll back and forth, up and down a little bit here, but I'm going to use this expression right here to help me determine my quarter points and to help me to determine the period of my function. So we're going to use the original period for sine, and the original period for sine is from 0 to 2 pi. So using that, sorry, wrong color. So using that, I know that 0 is going to be less than or equal to, my new value here is 3 times x plus pi over 3, and that's going to be less than 2 pi. And I'm going to use that expression to help me determine the new period of my function. So first thing is I'm going to divide 3 by 3, which again is one of the reasons why I have you factor out that 3, is it makes it much easier when you get down to here. So if I divide everything through by 3, that gives me that 0 is going to be less than or equal to x plus pi over 3, which is going to be less than 2 pi over 3. And then we're going to subtract pi over 3 everywhere. So we're going to do minus pi over 3, and we're going to subtract on both ends. So minus pi over 3 down here, and minus pi over 3 over here. Trying to solve that for x, so we can determine the new period of our function. So that gives me that 0 is less than or equal to x, which is less than 2 pi over 3 minus pi over 3. Oh, sorry. 0 minus pi over 3, that's going to give me negative pi over 3. My apologies. So negative pi over 3 is less than or equal to x, which is less than, take 2 pi over 3, subtract pi over 3, and that's going to leave me with pi over 3. So now my values for x, for my new function that we're graphing here, y equal to 4 sine of 3 times x plus pi over 3 minus 2. It's going to start at negative pi over 3 and end at pi over 3. So now I'm going to use that to find the period of my function. So the period of my function is going to be my last quarter point, which is pi over 3, minus my first quarter point, which is negative pi over 3. And that's going to be pi over 3 plus pi over 3, which is going to give me 2 pi over 3. So my new period is 2 pi over 3. So I'm going to use my period to break up my interval that I'm going to graph from negative pi over 3 into pi over 3 into quarter points. So I'm going to find my increments here, sixth thing. So my increments are going to be 1/4. It's always 1/4 of your period. In this case, my period is 2 pi over 3. So it's going to be 1/4 of that. So 1/4 of that is going to be 2 pi over 12, or pi over 6. So that's what I'm going to go by every single time, is I'm going to go by pi over 6, starting at negative pi over 3. So there's my first quarter point. So this value here, that is your first quarter point, and this value over here, pi over 3, that's your last quarter point, and we're going to jump by pi over 6 every single time. So we have our first quarter point at negative pi over 3. So our second quarter point is going to be negative pi over 3, and I'm going to add pi over 6. So I've got to get a common denominator. My common denominator would be 6, and so this is going to be negative 2 pi over 6 plus pi over 6. And so my second quarter point is going to be at negative pi over 6. Again, these are our x values that we're getting. My third quarter point. My third quarter point is going to be negative pi over 6, which was my second one, and again, adding that increment of pi over 6. So my third quarter point is going to be at 0. And then my fourth quarter point, I'm going to take my previous quarter point, which is 0, and I'm going to add pi over 6. And again, if you can just count by pi over 6s, you can do this a little quicker, but I'm going to make sure you see where I'm getting everything from. So 0 plus pi over 6 is going to leave me with pi over 6. And then my last quarter point, just double check to make sure, but if you take pi over 6 and you add pi over 6, that's going to be 2 pi over 6, which is where we said we were going to stop, which was at pi over 3. All right, so we're going to put all this together, and we're going to use all these values here, all of our quarter points. We're going to use our vertical shift, and we're going to use our center line. We're going to use all that, and we're going to use the basic shape that we have for sine to draw our picture here. So x and y axis, again, this doesn't have to be drawn to scale, but I do need to see where you label both the x and the y axis respectively. So our first quarter point was over here at negative pi over 3, so that's where we're starting. We're starting at negative pi over 3. And then we had our second quarter point, which is at negative pi over 6. And we had our next one at 0. And then our next quarter point was at pi over 6. And our last quarter point was over here at pi over 3. So there's our quarter points. Now we shifted our center line, which was normally the x-axis. We shifted that down 2 units. So we shifted that down to y equal to negative 2. So I'm just going to draw a horizontal line here at y equal to negative 2, just so you can see that center line that you're supposed to have for your graph here. It's our center line, y equal to negative 2. Now the amplitude was 4. So that means that we're 4 units above and 4 units below that center line. So if I go 4 units above negative 2, so 1, 2, 3, 4 units above, that's going to put me at positive 2. And if I go 4 units below, it's going to put me at negative 6, negative 3, negative 4, negative 5, and negative 6. So negative 5 and negative 6. So there is how many units I am above and below my center line. Now, this is where you need to know the original shape of what the sine function looks like. So the sine function starts right on the center line. So over here at negative pi over 3, we're going to put a point right here on our center line. And then at negative pi over 6, we're going to top out at our highest point there, 2. And then at 0, we're back on our center line for our sine function. At pi over 6, we're going to be 4 units below it, so I'm going to actually put it right in there. At negative 6, and then our last quarter point ends up right back on that center line there, pi over 3. And we're just going to draw a sketch of what that looks like. So sine function tops out there, turns, goes back down, bottoms out down here at negative 6, and turns, stops right there on our center line. So hopefully between this example and the examples you have in your notes, you'll have a good idea of what to expect and how to go through your worksheet and what to expect for your test questions and such.